Hello, and welcome to this video tutorial. Today I will show you the first part of how to build this robot. We'll take you step by step through the entire process, from connecting the components to writing the code that brings your robot to life. Whether you're a beginner or an experienced maker, you'll find valuable insights and tips to help you along the way. Join us as we explore the fascinating world of robotics, where creativity meets technology. Get ready to unleash your inner engineer and embark on this fun and educational journey. Let's dive in and start building your very own six-wheel robot. This is the 6WD motor structure, including 3 L298 modules as motor controllers. Take a good look at how everything's hooked up here. In just a sec, we'll check out the wiring diagram that shows what you're seeing right now. I know what you're thinking. These motors have definitely seen better days. But hey, that's actually a good thing. It proves just how tough and durable this chassis really is. Believe it or not, I've been putting this bad boy through its paces for over 5 years now. You see those battle scars? They're like a badge of honor for this robot. It's kind of like that old truck your dad won't get rid of because they don't make them like they used to. Same deal here. This chassis is built to last. So don't worry if things look a little worn. That's just proof of how reliable this setup is. These wires make up what I'll call from now data wire. Its job is to distribute information coming from the PCA9685 controller module. This module is a 16-channel PWM, pulse width modulation, controller that specializes in servo and LED control, generating up to 16 independent PWM signals, providing precise control over servo angles or LED brightness levels, offloading PWM generation from the main microcontroller, freeing up resources, allowing for easy expansion of PWM control devices in robotics and other projects. This versatile chip enables complex robotic movements, such as those in multi-jointed robot arms or quadruped robots, by coordinating multiple servos with just 2 communication wires, SDA and SCL, from the main microcontroller. Alright, check this out. This diagram is going to show you exactly how to feed power to your motors and modules without causing an electrical disaster. Pro tip: keep your high voltage lines and your PWM data wires totally separate. Think of it like keeping your coffee and your laptop apart. You definitely don't want them mixing. One wrong move with voltage, and you could fry your entire electronic setup faster than you can save short circuit. Check it out, folks. What we've got here is a power setup that's pretty sweet. We're looking at 4 lithium batteries wired up in series, with 2 of these series sets running parallel. Now, the real MVP here is the BMS, or Battery Management System, for those not in the know. This BMS is like the team captain for your batteries. It's got a few important jobs. It keeps all your batteries playing nice together, making sure none of them are working overtime while others slack off. It maintains a steady voltage output, so your robot doesn't get the jitters from power fluctuations. Here's the cool part: it doubles as a charger. Just hook up a 16.8 volt power source with controlled constant current to the right terminals, and you're good to go. Think of the BMS as your battery babysitter. It makes sure everything's running smoothly and safely, so you can focus on the fun stuff, like making your robot do awesome tricks. Remember, when it comes to batteries, especially lithium ones, safety first. This setup helps keep things under control and ready for action. Alright, folks, it's showtime. Get ready to see some real action in this part of our tutorial. We're about to witness these 6 DC motors respond in real time to the speed signals coming straight from an Xbox controller. How cool is that? Here's the secret sauce to make this magic happen. We've got a Raspberry Pi Zero as our brain. It's running 2 key libraries: Gamepad for interpreting those controller inputs, Serial to handle the wireless communication. So when you push that joystick, the Raspberry Pi translates that motion into commands, sending them wirelessly to our robot. It's like having a mini mission control right in your hands. Watch closely as each motor reacts proportionally to how much you're pushing on the controller. Gentle nudge, slow and steady. Slam it forward, Watch those wheels spin. This setup gives you precise control over your robot's movements. It's just like driving a RC car, but way cooler because you built it yourself. Time to get serious. This is part of the Python code that runs on a Raspberry Pi Zero W and is designed to read input from an Xbox controller and wirelessly transmit that data via a BlueSmurf Gold communication module, which requires serial communication with a Raspberry Pi. In this tutorial, we'll focus on the section of the code that handles joystick inputs. The code utilizes the gamepad library to monitor the controller's joystick movements and button presses. When the joysticks are moved, the code calculates the direction and speed based on their positions. For instance, it uses trigonometric functions to determine the angle of movement depending on how far each joystick is pushed. Key joystick handling functions include direction calculation. The code checks the axes of the joysticks to determine the angular direction using the atten function, ensuring smooth control based on user input. Speed adjustment. The right trigger's position influences speed, allowing for a gradual increase or decrease in velocity as it is pressed or released. Button presses. Various buttons on the controller trigger specific actions, such as adjusting servo positions or changing parameters related to movement. The rest of the code includes setup for serial communication and button handling, which will be covered in more detail in our next video tutorial. Thank you for watching this video. If you enjoyed it, please consider supporting me in coffee. You can check out the link in the description. May God bless you.